Okay, prove that there are an infinite number of primes of the form 6n plus 5. I've got sound here. Okay, so proof by contradiction. Assume finite number, i.e., so not an infinite number of primes of this form, just finite number, p1, p2, dot, 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 pk, where, and if we look at this, we can see we have pi mod 6 equals 5, or maybe I'll write it right around, pi equals congruent 5 mod 6. So each of these primes can be written of this form. Now, construct or let n equals 6 times all these primes minus 1. So you can see, because of this construction, some things we can note. No pi divides n. So basically n no, I'll just leave it like that. So no pi divides n because of how we constructed this. Okay. So now let's prime factorize this n. So that's prime factorize n. So n will equal some product of primes, which I'll call perhaps q, q1, q2, etc., q, let's say l. Okay, so we know that none of these q's could be one of these p's, because we just said no pi divides n. So we know that none of these I'll just say qi's could be in the set of the p's. So that's fine. Okay, that's fine. So let's have a look at a little bit more of the nature of these q's. So firstly note that n is congruent to minus 1 mod 6, which is 5 mod 6. Okay, so we're just looking at mod 6 now for the moment. So let's have a look at the q. So for each qi, so let's see, we could have 6 cases. So we could have qi is 0 mod 6, 1, 2, 3, 4, 5 mod 6. I won't bother writing qi and mod 6 at each time. Now this one here, no, that's not possible, because that would mean Qi is a multiple of 6, or in other words, not prime. So we reject that. This one here, that's okay. This one here, so if Qi was equal to 2 mod 6, that would be a problem, because it would mean, again, that Q is a multiple of 2, so Qi would be not prime, so that would be a problem. This one is not allowed because of the nature of n. This one is not possible. By construction of n. 4, again, this would mean that Qi is not prime. And this one here is okay. So we only have 2 possibilities here. Now, remember that n, which equals q, that has to be equal to 5 mod 6, and also each Qi is 1 or 5 mod 6. So we can't have it that they're all 1. We can't have all Q's being 1 mod 6, because 1 times 1 times 1, etc. That would be 1 mod 6, which of course is not 5 mod 6. So that means that at least 1 Q, let's say Q M, is such that QM is 5 mod 6. But QM is not in the list. So that means then we have a new prime not in the list, so like a contradiction. Okay. I think that's all to say about that.